In this video, we're going to take a look at a test review for a test on properties of derivatives, some basic differentiation rules. And so the first one asks, which of the, and there's some multiple choice in the first page, which of the following is a symbol for the derivative? And so A is not, there's a version of that we could change a bit to make it the proper symbol. This is not, if we put that prime after the y, that would be a correct symbol. This is a proper symbol for the derivative. It's called dy dx. Please do not call it dy over x. Okay, it's just dy dx. There's no over in it at all. And this is close. If we take that prime and move it over here between the g and the bracket, that would be a correct symbol, but as it is, it's not. In question number 2, we're asked, what's the derivative of 4x cubed? And this is my explanation here. So that 3 comes down and multiplies by the 4, and that's what I'm showing here. And then we subtract 1 from the exponent 3, so that's why it's 3 minus 1 up there. So 3 times 4 is 12, and then 3 minus 1, the exponent's 2, so that's why the answer is 12x squared. For the third one, what's the derivative of y equals the fifth root of x cubed? Well, you should write this as a power instead of as a radical function, and then you can differentiate. So when you have both roots and powers, the power is the top number of the fraction and the root is the bottom number. So that's why it's x to the 3/5. So using power rule, that 3/5 comes down in front, so we have 3/5 here, and then we subtract 1 from the exponent, so 3/5 minus 1. Now my common denominator would be 5. That's why I write the 1 as 5/5 here. And so 3/5 minus 5/5 would be negative 2/5. And so that actually is answer B, although I'm always going to write answers back in radical form instead of leaving with exponents that have negative fractions in them. So the 3 is the numerator, the 5 is the denominator, and x to the negative 2/5, well, that radical is going to be in the denominator. The 5 in the bottom is the root, so it's the fifth root of x squared. The 2 in the top is the power of x. Question number 4 asks, what's the derivative of negative 7 over x to the fourth? Well, it'd be a good idea to write this as a power first, and then you can use the power rule. So x to the power of 4 is same as 1 over, well, actually, we actually have the reciprocal of x to the fourth. It's a 7 on top, it's not 1. But when we bring that x to the fourth power up top, beside the negative 7, it would have a negative exponent. So notice there's a negative right there. And so now we can use the power rule because it's written as a power. So the negative 4 comes down and multiplies by the negative 7 front, and we subtract 1 from the exponent. So negative 4 minus 1 is going to be negative 5. Negative 7 times negative 4 is 28. And so to write this without any negative exponents, and that's a normal thing to do, you would write it as 28 over x to the fifth. Again, bring that power with the negative exponent in the denominator, and it'll change its sign. And so that's the answer for number 4, A. For number 5, what's the derivative of this function? And it's just a polynomial, so we can use power rule everywhere. So that 4 comes down and multiplies by the 5. That's 5 times 4. And we subtract 1 from the exponent. It was 4, so 4 minus 1 is going to be 3. The next one, the 3 comes down, so it's negative 3. And then x to the power of 3 minus 1, which is going to be 2. And then the next one, the 2 comes down and multiplies by the 6, and we subtract 1 from the exponents. Notice it's 2 minus 1 up there. This negative 8x, the x really has an exponent of 1 on it, so the 1 comes down and multiplies by the negative 8, and then we subtract 1 from the exponent. So it was x, 1 minus 1 is going to be 0 actually. And I put this plus 0 in the end because the 7 is just a constant. There's no x there at all. Remember, the derivative of a constant is 0, so that's why I put the plus 0 in the end. Final answer, I wouldn't bother to do that. So this is going to be 20x cubed, which is this term. This is going to be minus 3x squared, which is this term. This would be 12x to the first, or just 12x. And since 1 minus 1 is 0, x to the power of 0 is 1. So it's really just negative 8 times 1, which is just negative 8. So that's the correct answer for number 5. For number 6, we're asked, what is the derivative of 10x cubed minus 2 cube root x plus 6 sine x? Now, this minus 2 cube root x, I would rewrite that as minus 2x to the power of a third. The cube root is the same as the power of a third. So to differentiate 10x cubed, the 3 comes down and multiplies by the 10, that's what's here, and we subtract 1 of the exponents, that's why it says 3 minus 1 there. For this one, the 1/3 comes down and multiplies by the -2, so that's what I'm showing here, and then we subtract 1 from the 1/3, 1 from the exponent. So 1 is the same as 3/3, I'm just getting a common denominator. And the derivative of sine is cos, so the derivative of 6 sine x would be 6 cos x. Now, a little bit of simplifying. 10 times 3 is 30, and then in the exponent for x, 3 minus 1 is 2. 2 times the third is 2/3, and then 1/3 minus 3/3 would be negative 2/3. And then the derivative again of 6 sine x was 6 cos x. And so that's the final answer, which is C. For number 7, we're given that f of x equals r of x times h of x, and asked to write what f prime of x is. Now there's two ways to write this is the product rule, because the r of x and h of x are multiplied, hence the product rule. So if you start by differentiating the r and multiply by the h, this is what you're writing. So r prime times h of x plus, and then you do the opposite. I differentiated r here, but not h, so you do the opposite here. So we differentiate h and multiply by the r of x original function. So that's a correct way to write the derivative of this. Now, you can instead start with differentiating the h and multiply by the r plus, and then do the opposite, plus r prime times h of x. So both of those are fine. There's nothing wrong with either of them. So the only correct one, let's see here. This one here is the same as this. So that's why A is the correct answer for number 7. In part 2, you're asked to do some differentiation. And so the first one here, h of x equals 4 over 3x squared plus 7x minus 8. So my suggestion here is to rewrite this as a power, and then you can use power rule for everything. So the x to the power of 2 in the denominator, when you bring it up, it would be x to the minus 2. So to differentiate this, the negative 2 gets multiplied by the 4/3. So negative 2 times 4 is negative 8, so that's going to be negative 8/3. And we subtract 1 from the exponent. Negative 2 minus 1 would be negative 3. The derivative of 7x is just 7. Remember, there's actually an exponent of 1 here, so that 1 comes down and multiplies by the 7. And you'd actually have, when you subtract 1 from the exponent, you actually would end up with 0 here. And we won't normally write x to the power of 0, so we would normally just write that as 7x. And we'll just delete that. And so I would always write final answers with positive exponents. So this x to the power of negative 3 would come down on the bottom with the 3 in the denominator and be x to the power of positive 3 there. For question B, g of x equals 5x negative 3 times this trinomial. So my suggestion, you could use the product rule here, but my suggestion would be to expand that 5x to the negative 3 into this trinomial and then differentiate. So when you multiply these, 5 times 2 is 10. X to the power of negative 3 times x to the power of positive 3. Remember, we're multiplying things with the same base, which is x. So you add the exponent. So negative 3 and 3 add to 0. So that's why it's just 10. You could write as 10x to the 0, I suppose, but you don't really need to write the x to the 0. So 5x negative 3 times the 4x to the 4th. 5 times 4 is 20. When we add the exponents when we're multiplying, negative 3 plus 4 is positive 1, so it would be 20x here. And multiply this by the last term. 5 times negative 2 is negative 10. And when we multiply x to the negative 3 by x to the power of positive 5, you add the exponents. So negative 3 plus 5 would be 2. So that's why it's negative 10x squared. And so that's the function simplified. Now we differentiate. The 10 is a constant, so its derivative is 0, so that's why the 10's gone. The derivative of 20x would just be 20, just like when I differentiate the 7x, it was 7. The derivative of any number times x, any constant times x, is just a constant. And then the derivative of negative 10x squared, the 2 comes down. 2 times negative 10 is negative 20. Subtract 1 from the exponents, that's why it's just x the first here. For the next one, we'll scroll down to C here. And so we're given f of x equals this function. You're asked to use the product rule here. So in this kind of question, you'd be asked to demonstrate how the product rule works. So I generally start in the product rule by differentiating the first function. And so that's what I'm doing here. Derivative of 5x cubed would be 15x squared using the power rule. 3 times 5 is 15. Subtract 1 from the exponent. The derivative of negative 3x squared would be negative 6x. The 2 comes down and multiplies by negative 3 to make negative 6. Subtract 1 from the exponent. That's why there's a 1 here. So derivative of the first function, which is this, times the second function. I'm not differentiating that yet. Plus, and then you do the opposite. So we write down the first function times the derivative of the second. The derivative of 7x to the fourth, the 4 comes down and multiplies by 7, so that's 28. Subtract 1 from the exponents, that's why it's 3. And the 3 on the end, the plus 3 is just a constant, so its derivative would be 0. So that's why we just get 28x cubed here. So now I would expand these two pairs of binomials out and collect like terms. So 15x squared times 7x to the fourth is 105x to the 6. 15x squared times 3 is 45x squared. Negative 6x times 7x to the fourth would be negative 42x to the fifth. Remember, you add the exponents, so 1 and 4 add to 5. And negative 6x times 3 is minus 18x. Now expand the 28x cubed into here. So 28x cubed times 5x cubed would be 140x to the 6. And 28x cubed times the negative 3x squared would be minus 84x to the fifth. Remember, you add the exponents, so 2 and 3 add to 5. And so we collect like terms. There are two terms that have x to the sixes, this one and this one. And so we add those, we get 245, x to the 6. And then there's two terms that have x to the fifths, the minus 42x to the fifth and the minus 84x to the fifth. So 45 minus, negative 42 and negative 84 add to negative 126. And then we have 1x squared term, that one, and then the minus 18x after it. For D here, I've put a hint on the answers here. The hint is, if you don't want to use the quotient rule, then divide that 3t, into all three terms. So simplify it and then differentiate. So 9t to the fourth divided by 3t. Remember, 9 divided by 3 is 3, and you subtract the exponents. There's really a 1 right there on that 3t. So 4 minus 1 is that 3. When you divide these, negative 3t cubed by 3t, you get negative 3 divided by 3 is negative 1, and 3 minus 1 would be 2. And so next we would divide the 6t squared by the 3t. 6 divided by 3 is 2, and then 2 minus 1 is 1, so just 2t to the first. And then we would use power rule. So 3 times 3 is 9, subtract 1 from the exponent. Derivative of negative t squared is minus 2t, and derivative of 2t is just 2. For question E, we're given this function, and so to differentiate 5e to the 3x, it's the original function times the derivative of the exponent. Now the derivative of 3x would be 3, that's why we're multiplying by 3 here. For the next one, the derivative sign is cos, so the derivative sign 7x is going to be cos 7x. Now, the 1/3 is still in front, so we write a third. Derivative sine 7x is cos 7x multiplied by the derivative of the 7x. That's actually the chain rule there. That's the derivative of the inside function, which is the 7x function. And then derivative of 8x is 8. So 3 times 5 is 15, e to the 3x. And so when we multiply 7 by negative a third, we get minus 7/3, and cos 7x plus 8. For f here, we're asked to differentiate 8e to the 3x to the fourth. So to differentiate a power of e function, you take the original function and multiply it by the derivative of the exponent here, the 3x to the fourth. So the derivative of 3x to the fourth would be 12x cubed. 4 times 3 is 12. Subtract 1 from the exponent. And so that would end up getting multiplied by the 8. So it's 96x cubed. E to the 3x to the fourth. And G, finally on this page, cos 4x over the cube root of x to the fifth. So I'm going to rewrite this as a product so I can use product rule. So this would be x to the 5 over 3, And so when you bring it up, the sign changes. So that's why it's x to the negative 5/3. Maybe it's hard to see, but there's a negative 5/3 there. So to use the product rule, I'm going to start by differentiating the cos 4x. The derivative of cosine is negative sine. So it'll be negative sine 4x times 4, because that's the derivative of the 4x. Just like up here a moment ago, I multiplied by 7 because that was the derivative of the 7x. Same idea. Or I multiplied this by the derivative of the 3x to the fourth here. Same idea. So, the derivative, again, cos 4x is negative sine 4x times 4. So that, right there, is the derivative of cos 4x times the second function. So I differentiate the first function multiplied by the second. And we go plus, and then the first function times the derivative of this. So the negative 5/3 comes down in front. There it is right there. And we subtract 1 from the exponent. So if you have negative 5/3, and you subtract 1, 1 is the same as 3/3. So that would give you negative 8/3, and so that's why there's a negative 8/3 right there. Now to simplify this, I would write negative and then bring that 4 in front. So 4 sine 4x, that's that. And then this exponent on the x is negative, so I'll put that root in the denominator. Remember, the bottom number in the fraction, the denominator is the root, so it's the cube root, and the top number is the power. So it's the cube root of x to the fifth. And then for this one, negative, now 5 on top, 3 on the bottom, so negative 5 on top, 3 on the bottom. Cos 4x, on top. And then x to the power of negative 8/3, similar to this one, since the exponent was negative, we'll write it in the bottom. So the 3 means the cube root, so we put a cube root of x to the 8th there. And that's question G. For question number 2 here on the next page, you're asked to consider this function. You're asked at what point or points does the curve have a tangent line slope of negative 9? You're asked to find all such points. And there is a hint here. Remember, the derivative gives the slope of the tangent at any point. So here's our function, 12 plus 3x squared minus x cubed. So we find the derivative. 12 is a constant, so its derivative is 0. The derivative of 3x squared using the power rule would be 6x. 2 times 3 is 6. Subtract 1 from the exponent. Derivative of x cubed would be 3x squared, so bring the 3 down. Subtract 1 from the exponent. So that's why it's 6x minus 3x squared. Now you're asked to find at where does the tangent line have a slope of negative 9? So this gives you the slope of the tangent if you only knew what x was at a particular point where x is. X is x. So that's why we would set this equal to negative 9, because that's going to give you the slope for any x. So we set the 6x minus 3x squared equal to negative 9. And so I'm going to do a little bit of rearranging. Just so I have everything positive, if I bring the negative 3x squared, if I bring it to the right side, is positive, and the 6x would be negative. So I actually would have positive 3x squared minus 6x minus 9. And so I'm just going to switch sides. And then I get 3x squared minus 6x minus 9 is equal to 0 when I bring everything over to one side. Now you can divide out of 3. All these coefficients divide evenly by 3. I didn't show the 3 factored out here. I'm just dividing both sides by 3. So it becomes x squared minus 2x minus 3. And so we're going to factor that now. So look for two numbers to add to negative 2 and multiply negative 3. And that would be negative 3 and 1. So this would factor into x minus 3 and x plus 1. So we set that factor to 0, we get 3. This factor, we get negative 1. So it appears that there are two places where the tangent line has a slope of negative 9. And so when it says at what points, that means an entire ordered pair, not just the x coordinate. So the last thing to do here in question number 2 would be to find the y values that go with each of these x's. So we would take the 3 and we substitute in place of x in the original function. So the y value where x is 3, we would go 12 plus 3 times 3 squared minus 3 cubed. And so 3 squared is 9 times 3 is 27, and that's minus 27. So those actually add to 0, and we get 12 for the y coordinate. And then we put negative 1 in instead. So negative 1 here and here, and that works out to be 16. So we put 3 in and we got 12, so 312 is 1 point. And then we put negative 1 in and we got 16 for the y coordinate. So there's actually 2 points here where the slope of the tangent is negative 9. They're at 312 and negative 116. In question number 3 here, the owner of an apple orchard estimates that if he or she plants 24 trees in an acre of property, then each mature tree will yield 600 apples per acre, so each one is. Now, for each additional tree planted per acre in every acre, the number of apples produced by each tree starts to decrease. So he or she is assuming it's about 12 apples they lose per tree due to overcrowding. Of course, the more crowded the trees are, the less they're going to produce. So you're asked in A here to use the calculus to determine what's the optimal number, or how many apple trees per acre should he or she plant to maximize the total crop, the number of apples they're going to get from an acre of property. So we're going to call delta t the number of extra trees above 24 that they're going to plant per acre. Now, here's a general formula, and we're going to write it more in an algebraic sense in the next line. The number of apples per acre would equal the number of apple trees per acre multiplied by the number of apples you get off each tree. And that would give you how many apples there are from a certain acre of property. Now, so we're going to call A the total number of apples. So the number of trees per acre starts at 24, and we're going to add to that delta t. We're going to add to it a certain number of trees. We don't know what that is yet, but we're going to find that. So that's the number of trees in an acre of property. The number of apples per tree starts at 600, and we're going to subtract from that 12 times delta t, which means we're losing 12 apples for every extra tree above 24 that we plant. So that's the formula to give the number of apples depending upon how many extra trees you plant. So if I want to find the maximum value for this, I'm going to set the derivative to 0. So I'm going to multiply this out. I suppose it could actually use product rule here, but it's not really necessary. They're actually fairly small expressions, so it's pretty quick to expand it out. So multiplying out, 24 times 600 is 14,400. 24 times minus 12 delta t would be minus 288 delta t. And then delta t times 600 would be 600 delta t. And then delta t times negative 12 delta t would be minus 12 delta t squared. And then combined like terms, these two delta t terms in the middle add to 312 delta t. And so to find the derivative, the 14,400 is a constant, so its derivative would be 0. The derivative of 312 delta t would be 312. And using the power rule again, the derivative of negative 12t squared, the 2 comes down and multiplies by the negative 12, to give you negative 24 delta t. So that's the derivative. The maximum occurs where the derivative is 0. And so in the top of the next page here, we're going to set that 312 minus 24 delta t equal to 0. And so I might think about bringing the 24 delta t over to the right side, even though I have it written on the left. You would have 24 delta t would equal to 312, which is what I have written here, just two sides flipped. And then we divide it to 24. So we get delta t is 13, which means we should plant 13 extra trees above the 24. So 24 and 13 would be 37, so it's best if we plant 37 trees in an acre, and we'll get the most possible apples. Now in B, you're asked to give a reason, and I have 2 listed here, why this represents the maximum possible crop. And so reason number 1 is that this, the undifferentiated function, the apple function, if you will, is a negative quadratic. And a negative quadratic, if you graph it, looks something like this. It's a parabola that opens down. And so it has a maximum point, not a minimum point. And so that's one reason why what we got for our solution would be the highest possible number, the maximum. Another reason is we could take this area function, and if you put 13, which is what we got the delta t is to equal, which gives us the 37 trees. If you put 13 in place of delta t, 14,400 plus 312 times 13 minus 12 times 13 squared works out to 16,428. So that would represent the number of apples, the maximum number of apples you're going to get from an acre of property. Well, if instead of 13 we put 12, so one less, or 14, one more, in both cases those work out to 16,416. 16,416. So notice that the 16,416s are less than the what we think is the best, the optimum. And so this is going to be the maximum. We put delta t at 13, we get 16,428. On either side of it, we get a smaller amount. So that's another reason why that would give us the maximum possible number of apples from an acre of property. And then we have a bonus question down here to differentiate this h of x function using the quotient rule. And so the quotient rule works like this. Here's the function, and we start with the denominator. So the 9 minus 2x squared gets multiplied by the derivative of the numerator. So the derivative of 5x cubed would be 15x squared. Remember our power rule, 3 times 5 is 15. Subtract 1 from the exponent to make it 2. Derivative of negative 3x squared, the 2 comes down and multiplies by the negative 3 to give you negative 6. Subtract 1 from the 2, you get a 1 for the power of the negative 6x. Actually, really, the x power is just the 1, not the 6. And then we go minus the numerator expression times the derivative of the denominator. Well, the 9 is a constant, so its derivative would be 0. But the derivative of negative 2x squared would be negative 4x. Again, 2 times negative 2 is negative 4. Subtract 1 on the x, so it becomes power of 1. And it's all over the denominator squared. So the 9 minus 2x squared, all squared. So in order to simplify this, I would just expand it out and collect like terms. And that's probably the simplest form you'll write it. I won't bother expand out the denominator because it's already in a factored form. It actually really becomes bigger when you expand out the denominator. So 9 times 15x squared would be 135x squared. 9 times negative 6 would be negative 54x. Negative 2x squared times 15x squared would be minus 30x to the fourth. And negative 2x squared times negative 6x would be plus 12x cubed. And then negative 4x times 5x cubed would be negative 20x to the fourth. And then that sign changes to plus 20x to the fourth. And negative 4x times negative 3x squared would be 12x cubed, and again that sign, when we take the brackets off, change it to a negative 12x cubed. Notice that these 12x cubes are opposites. One's positive and one's negative, so we could actually just cross those out. They add to 0. And so I'll write it from highest power to lowest power. And so there's a 20x to the fourth and a negative 30x to the fourth, so they would add to negative 10x to the fourth. And then there's the x squared term. Remember, the x cubes added to 0, so plus 135x squared. And then there's just the minus 54x, and it's over the 9 minus 2x squared squared. And so that is the derivative using the quotient rule.